Imagining a scenario where all the water on Earth evaporates is not only terrifying, but also a window into understanding the fundamental importance of water. The consequences of such an occurrence would be immediate and catastrophic, affecting life, climate, and the very geology of our planet. Initially, terrestrial life, which is entirely dependent on water, would face an existential crisis. Human bodies, composed of approximately 60% water, would begin to dehydrate rapidly, leading to severe physiological malfunctions and, eventually, mortality. Plants, too, would wither and die without water for photosynthesis and nutrient transport, leading to a collapse of the entire food chain. Animal species that rely on plants and other water-dependent organisms would follow suit. The extinction of flora and fauna would create a lifeless desert, barren of any vegetation or wildlife. The atmospheric changes would be equally drastic. Water vapor is a critical greenhouse gas that helps regulate the Earth's temperature. Without water vapor, the planet would lose a significant amount of its heat, plunging surface temperatures. Deserts may experience even more extreme temperature fluctuations, whereas regions that were once moderate could become inhospitably cold. Additionally, rain, snow, and all forms of precipitation would disappear, rendering the water cycle obsolete and ending any chance of water returning to the surface through natural means. The hydrosphere's disappearance would also affect geomorphological processes. Rivers and lakes erode landscapes and redistribute sediments, shaping the Earth's surface. Without these processes, erosion would cease, leading to stagnation in landscape evolution. Coastal regions, which are constantly reshaped by tides and waves, would become static. Not just biologically, but geologically, Earth would lose its dynamism. On a broader scale, the lack of water would halt biochemical cycles essential for life, such as the carbon cycle. Oceans act as significant carbon sinks, absorbing CO2 and mitigating global warming. Their absence would exacerbate atmospheric CO2 levels, potentially creating a runaway greenhouse effect, despite the initial cooling from the loss of water vapor. In terms of possibilities, human ingenuity might attempt to find alternatives for water or create synthetic versions to preserve some aspects of life. Potential technological innovations could include artificial hydration methods or simulated water bodies using advanced materials. However, these would be mere stopgaps and not a replacement for the complex and irreplaceable interactions facilitated by natural water. The Earth's health, both biological and geological, would deteriorate rapidly. The planet would transition from a vibrant, life-supporting system to a lifeless, dry rock. The biosphere's collapse would have cascading effects, and the Earth would closely resemble other barren planets in our solar system, like Mars. In conclusion, the evaporation of all water on Earth would spell the end of life as we know it. The intricate balance maintained by water's presence in biological, atmospheric, and geological processes underscores its irreplaceable significance. Life, climate, and the very fabric of Earth systems would be irreparably altered, leading to a desolate and static planet. This thought experiment underscores the invaluable role water plays in maintaining the delicate equilibrium of life on Earth.